Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Welcome to the another video to the world of carbon nanotubes. How are carbon nanotubes made or how they are synthesized? There are several methods. Arc discharge method. It involves the vaporization of the graphite electrodes in an inert gas. It produces a high quality single wall nanotubes and multi-volt nanotubes. Laser ablation process. A pulse laser, it vaporizes a carbon target in a high temperature furnace. It yields a high purity single wall nanotubes. So laser ablation method is one of a famous method. Then the most common method is chemical vapor deposition process. So there are different types of chemical vapor deposition process. Hydrocarbon gas decomposes over catalyst particles. This is currently the most scalable method for controlled growth on substrates. So there are different forms of chemical vapor deposition process and they are currently used vastly. Significant challenges remain in achieving high purity, specific chirality, and cost effective large scale production. Real time applications. So, it has good applications in the electronics and energy fields. You have flexible displays, transparent conductive films made from the carbon nanotubes. They are replacing the indium tin oxide in flexible OLED screens. So, for example, it's like the prototypes from the Samsung. Then battery electrodes. Carbon nanotubes enable faster charging and increased capacity in lithium ion batteries. So they boost performance at least by 30 percentage, and also the cycle, that is the cycle of the battery, is increased due to the use of the carbon nanotubes. High frequency transistors. So here the IBM has demonstrated the carbon nanotube transistors operating at 100 gigahertz, surpassing the silicon and paving the way for the future high performance computing. And next is the supercapacitors. Their high power density makes them ideal for rapid charge discharge cycle in electric vehicle and consumer electronics. So it has a major role in the energy sector. So now more researches are being made in the electric vehicles. So carbon nanotubes are playing a very major role in this. So real-time applications in materials and also in the medicines. So advanced materials. Carbon nanotubes are transforming materials with their exceptional strength and conductivity. Lightweight composites. So reinforcing plastics and the metals for the aerospace, reducing the aircraft weight. It reduces by about 50 to 20 percentage. And also it enhances the sports equipments like tennis rackets and bikes with increased stiffness. And also conductive plastics. It's used for shielding and anti-static coating in sensitive electronic devices. So in the biomedical and the medical, it has a groundbreaking potential for targeted therapies and diagnostics. So drug delivery system, enabling the targeted delivery of the chemotherapy drugs to cancer cells. So it reduces the systemic toxicity in preclinical trials. Biosensors. These biosensors are highly sensitive detection of glucose for diabetes management, and also it has a specific biomarkers for the early disease diagnosis. Tissue engineering scaffolds, so mimicking the natural extracellular matrix for the regeneration and bone repair. These are the excellent applications in the biomedical fields. It's really fascinating to know about all these things. Let's meet in the upcoming video. Thank you.